moderator for this session. And before we get going here, just note if you do have a question, you can post it in the Q&A. We'll field questions at the end of the session. I'd like to start out by first again welcoming you to the Cause Research Keynote Address. My name is V.N. Bimmel-Rao, and I'm honored to introduce to you today Professor Dr. Rolf Biehler. Dr. Biehler has an illustrious career as a researcher and teacher at a couple different institutions, the University of Bielefeld, the University of Kassel, and most recently at the University of Paderborn, at which he is a professor emeritus. Throughout his career, Dr. Biehler has made significant contributions to mathematics, statistics, and data science education in terms of both students' learning as well as teacher education. In particular, his work has helped us understand and support students' use of digital tools that are designed or adapted for doing and learning statistics and data science. You can find more information about Dr. Biehler's many contributions to our field on the eCOTS online program, and I encourage you to do so. Today, Dr. Biehler will discuss how we can contribute to students' understanding of new machine learning methods and their applications in science and society. So without further ado, please join me in welcoming Dr. Rolf Biehler.
Yes, thank you. Welcome to my presentation. Thank you very much to the organizers for inviting me to this honorable keynote talk at the Electronic Conference on Teaching Statistics. It's a pleasure for me to give you some insights into what we have done recently and what we are still doing. So I try to share my screen. So, okay, you can see my screen, I hope so. Otherwise, somebody should protest. Okay. Okay, the title of my talk is Classification, Decision Trees and Machine Learning as a part of secondary education. And the work I'm presenting today is joint work with Yannick Fleischer. Yannick is my PhD student since several years, and he is actively working in the project, and we have developed these things together. So I have to see how there's a problem with forwarding the slides. Aha, okay, here we are. So I'm working since 2018 in a project called ProDavi. It's funded by the Deutsche Telekom Stiftung in its third phase now. It is unique in Germany. That's an interdisciplinary project between the didactics of mathematics and didactics of computer science. And also our team has two members from the computer science didactics and two of didactics of mathematics. The outline of my talk, I will present an overview, a short overview over our project. Then I will talk about rethinking modeling and bivariate data analysis in secondary statistics education. I will first of all present some arguments why I think that decision trees are or should become an important part of secondary education. And then I move on to show how we teach predictive modeling in the courses we have developed material for. Then last but not least, I show you a teaching unit, a brief sketch we realize in grade 5 and 6 with data trees unplugged and use data cards for this purpose. I probably will not have enough time to present you more information about our Jupyter notebooks and how we use Python and things. So I will briefly mention this before, but not at great length. So what does the ProDavi project do? We develop teaching material. We develop also tools, digital and unplugged ones. I mentioned already the data cards. We heavily use CODAP, which is probably well known in your country, and especially the AVA plugin, which is supporting decision tree creating. Then we also use Jupyter notebooks with Python. and we adapt professional libraries for teaching purposes. And we have various versions of Jupyter notebooks. Some of them are just menu-based, so the students do not see the code behind the scene, so to speak, and others are designed that the code can be shown and accessed and manipulated if needed. We have professional development courses for teachers, and we work on theoretical educational frameworks and do classroom research. So our whole project started 6 years ago in a project course in grade 12. So we work in classes, and this is a non-obligatory course in grade 12, but the students can choose this course. And if they choose a course, they get a grade, and the grade goes into the final examination grade. So it's whenever they have selected such a course, it's in a sense obligatory for them. And we use this as a kind of experimental field to try out new ideas with very bright students. So the students all of them had a background in computer science already, so some programming languages they could use. They had no knowledge about Python, so that was newly introduced to them. And we started the course with introducing a data project, and that was the very end of the course. In the end, they had to program an app and develop an AI system as a result of the whole course. And was the overall structure of the course. And we inserted modules with different topics, with providing knowledge to them which they need for doing the project work. So we started with data exploration with Coded, then we had a short Python course, and then we used data exploration with Python, Jupyter notebooks. And then we had two modules, one on decision trees and one on neural nets, and with different data sets. And they use this knowledge then to build an application. And the topic was predicting parking lot occupancy in the city of Paderborn. So that was a gymnasium in Paderborn. We collaborated with local authorities, and they gave us live data on parking lot occupancy, and the students developed a system to predict how many spaces will be free in the next hour or so, and they used data from the last 20 years and try to make a good prediction. So that was the starting point. And in the next step, we took some of these modules and developed them for grade 8 to 10 to make it easier, accessible to younger students. Not the whole project course, but we had a unit on data exploration, and another unit on data exploration and epistemic programming. That is some notion we use, that programming is used to develop new knowledge, which is a new idea for computer science education, at least, because they often use, of course, programming languages to develop programs. But we introduced this idea to use programming for developing knowledge. We have a machine learning with decision tree unit and a new unit about data awareness, so that the students become aware when they use data-driven digital devices, what kind of data are collected and what the companies do with this data. These are taught in grade 8 to 10, also in computer science classroom. Computer science is not obligatory in our state, but the students can choose it. And if they choose it, there is a freedom to suggest things and topics, because the curriculum is not very strictly determined. So we have a lot of freedom. In contrast, if you go in a mathematics classroom, for example, the curriculum is full and you can do nothing else. So there's a little bit data exploration, maybe 2 weeks, that's all. So we needed some favorite conditions to find out what ideas will work and how can we test our material with real students and so on. Then we had it was a little bit a surprise that our state decided to make computer science obligatory for all grade 5 and 6 students. That's a really challenge for all the teachers, because most of the teachers have not studied computer science. They have to get specific courses to train them. And we got into contact with those who made the syllabus, and we managed to get data awareness and decision trees into the curriculum, and also the data cards, I will show you later, were well received by the teachers because they are unplugged and easily usable by the students. So that is the background of what we have done. And we have new plans. We plan to realize an integrated STEM course, including the earth science. We have tried to develop new topics like analyzing self-collected environmental data with a sense box. We plan to have a topic on climate change, including mathematical ideas of different types of regression. And another unit is about genome data. So that is in the planning stage. We will start this this elective course in the fall of this year. So I will not say more about this, and we use two tools, CodeApp and Jupyter Notebooks, and with a limited knowledge of Python. And the second half of the school year is again a project phase, and the students can select their own projects within these contexts, and they can also decide whether they intend to use CodeApp or whether they want to use Jupyter Notebooks and do a little bit of coding and programming. So let's rethink modeling in statistics education. From the perspective of data science and machine learning, we should include regression and classification problems. So classification problems are not part of the mathematics curriculum in Germany, at least. The regression is a little bit touched upon. And it's of course central to consider also multiple variables in the modeling process, not just one or two. And also to be open, which is at least for the mathematics classroom unusual, that models can be expressed by algorithms as well as by formulas. Another new idea which comes from machine learning is in prediction. This is not something which has been highlighted so far in our modeling sessions in the mathematics or computer science classroom. So prediction is a new idea which is new highlighted from when we come from machine learning context, which is also what is also very important and which is not common in our modeling classes, neither in mathematics nor in computer science, is to use really different types of data set. One data set to develop the model, the training data set, and then to test the model or a different one. And then you use maybe also a third data set and for evaluation of the model you have created. Or also you might wish to monitor the performance of the model on future data. So that is a new idea. I mean, that's not so new for natural sciences. You develop models on one data set, and of course, a model which has been developed has to be tested on future data. Otherwise, this is the essence of the scientific methods. But nevertheless, this has not been practiced so intensively in the classroom. We have, of course, new types of uncertainty, depending on not only the probabilistic one, depending on the uncertainties in the data we use. So we have a little bit in our curriculum analysis of relations between two categorical variables. Descriptive modeling, for example, how is gender and Instagram use related? We can students can create two-way tables and compare these variables and see whether they see some relations. We have also, as part of our curriculum in the mathematics part, Bayesian predictions, for example, COVID testing or other things, which has become very prominent as a topic at school level, of course, during the pandemic, when many pupils read and heard about this testing and about the errors, which can be made different types of errors. We have notions like bait race, incidence, specificity and sensitivity of a test, and also this inverse question, which we know from a lot of research, it's difficult to understand by many people. If you make the inverse conditional probability, what is the probability of being infected when the test is positive? All these things were discussed during the pandemic in newspapers, and also schools took this up. And machine learning can, if you introduce classification, can take up this. They can really relate these new topics to this Bayesian predictions, which have some place in the curriculum. And important notion, I come back to this later, is the confusion matrix with different error types, and also the notion of precision in machine learning is related to this inverse conditional probability. And of course, in machine learning, you make predictions and you can make wrong classifications, and you have to distinguish different types of misclassification rates. So this is maybe a reinterpretation of a health test matrix reinterpreted as a confusion matrix with two different types of misclassifications. So traditional, to summarize, we have descriptive modeling and Bayesian predictions and judgments, and new perspectives for machine learning include predictive classification, use several predictor variables, not just one, and also, and that is of course an important point, can we construct such classifiers from data semi-automatically or totally automatic? And machine learning as such starts with this topic, of course. When there is an then a machine learns from data and creates a decision tree. But that the student should not start with this. But we will show you that we lead the students in several steps to the machine learning algorithm. So some arguments. Is classification part of secondary statistics? Richard, you will know better than I. The GACE guidelines. Okay, the GACE guidelines may not describe what is common in your classrooms, but I realized that there was an interesting change between the GACE guidelines on 2005 and 2020. Now classification has become part of the recommendations of the GACE group. And for example, they have this, you may know it, the lizard data predicting the type of habitat where lizards come from, whether they are healthy or not, and from different measurements. And here we have, I quote from the GACE guidelines, here we have a kind of a decision tree. And I think I have to move a little bit I don't see my slide completely, so I think it's about 10% misclassification rate or so. So that has become something in your country as well to take into account. What GACE does not recommend is, as far as I understand it, to do machine learning in high schools. But that is something we want to introduce, so we do not stop in creating decision trees manually, but also to move in the direction of understanding how a machine can do this. Okay, I have problems again okay. So what do? We start in our project with a manual creation of decision trees, but what are good heuristics to do that? How do we come to such a decision tree? What are guidelines for students? Then we use, and I will show you in more detail, a semi-automatically creation with tool support. So we use CODEP for data analysis, and use the ABA plugin to support students in testing several decision trees and compare them. That would be very difficult to do by hand, and it would take a lot of time. So that is a first step of using technology for this purpose. Then the next step is, we call it playing the machine. How can we represent the learning algorithm in a kind of pseudocode to understand how a machine might work step by step to create a decision tree? And if students have understood this, and we have prepared Jupyter notebooks where they can experiment with these implemented learning algorithms. So we call this as a kind of a gray box approach. It's not completely transparent what happens inside this box, but they have developed a mental model on when playing the machine. And so they have a kind of algorithmic understanding of what is happening behind the scenes. They have also some options for parameter choice. I will point to this later. So some arguments for decision trees. Decision models use multiple predictor variables. And that is something which Rob Gould already highlighted years ago when he created his one of the first data science courses in Los Angeles, that it's easier to understand with as compared to multivariate regression. Decision tree models can also have to be expressed as algorithms. And so this introduces a new type of model, and we think that is also an important point. So decision trees can also exemplify machine learning. We make distinctions between different types of machine learning, unsupervised, supervised learning, and reinforcement learning. And and classification is part of supervised learning, and neural networks as well. So we focus on this type of machine learning. It's a good example which leads to transparent models. And that is a big difference compared to neural networks. Some computer scientists criticize our approach because they say, well, your decision trees are not so representative of what is done in artificial neural networks, and this is more or less not transparent what happens inside a neural network. This is, of course, a big problem when using these neural networks, and we have developments. We try to counteract this intransparency by creating a so-called explainable artificial intelligence and things. Nevertheless, we think we should start with transparent models. In our grade 12 course, we also introduce the students to neural networks, and we have also a course on neural networks for 9th grade, but I will not mention this for today. And also another argument for decision trees is the whole workflow of supervised learning can be already learned with decision trees, and one can build on more complex models later on. We can, a big problem of AI models is so-called overfitting, that you have training data and the model fits very well to the training data. And if you go over to test data, the fitting gets very bad. And that is an overall problem with all types of models, and we can address this, and I will show you some examples. Students can get some insight into this problem already when they work with trees. So, and we can also, and that is also, I think, important, we can discuss the pros and cons of automation and the role of humans in artificial intelligence. So the students start with creating their own decision trees, and then they can compare it to what the machine provides. And often the simple tree the students have developed is not that much worse than a machine algorithm. There's also a discussion about this topic in computer science, of course. So DTs are teachable. One can start intuitively with decision trees. So there is a big literature on this topic. Martin Yorn, Tim Erickson, you will know, from the United States. Transparent, simple, and robust, fast, and frugal trees. So also such psychologists and decision researchers often try to improve decision-making capabilities of humans by using robust, fast, and frugal trees. And so we can also relate to this discussion when we support students in manual creation. We can gradually progress to more automated procedures. The tools are manifold, from data cards, CODEP, and Yuka, I mentioned it already. So now, how do we do decision trees? Well, I have to say we have 3 parts, and I will not have time today to go into depth into the reflect on responsible use of ML. in a society. So I will focus on creating database models and exemplifying the workflow of machine learning and how we elementarize this. So this we in our teaching we use one example. We have GIMS, a so-called GIMS study, use information media is the translation. It's published every year or every second year. It's a representative survey of how young people use media, what kind of devices they own, and so on. And they compare and they report different age groups and girls and boys and so on. And so this is a very well-known study. And what we did, we asked the authors of the study to give us their questionnaire, and then we collected our own microdata of about 1,200 teenagers and ask our students to analyze these data sets. And that is, of course, different, very different from reading the GIMS studie. You have good graphs and comparison, but all the data are aggregated. And what we want the students to do is to work with the original raw data and find their own insights and about this topic. And they can also, of course, find their own research questions with which they go and look at the data set. So the topics are, I mentioned it, are very diverse. We have 160 questions, so it's a really 2,200 teachers. Well, the big data, people will not say it's really big data. No, it's not really big data, but for the students, it's really big data because they normally in German schools never confronted with such a huge data set with 160 columns and 1,200 rows. That is really big for them. And because maybe that's also in some classrooms in the United States, many German schools use toy data, very small data sets which you can more or less analyze by hand. So that is a really different thing. And grade, age and genders is of course asked. Then we have owning digital devices. How often do you use online platforms? Do you use classical media like newspapers and so on? How do you use game and so on? So we use this, we have this data set. And we use it on the one hand in our unit on data exploration, and on the other hand on introducing decision trees. And so one example which is just in print this week. So we with a colleague, I edited a teacher journal, Mathematiklehren, teaching mathematics, and it's devoted. The whole issue is devoted to artificial intelligence in mathematics education. And we had one example, and we gave it the title, How TikTok Can Find Out Your True Age. You know, this was a problem. I know TikTok is always a problem and remains to be a problem in many countries. But there was this question of should people get access to TikTok if they are below 13? And if it's not checked, they may just do it. So what we wanted to discuss with our students, is an activity I'm developed together with Yannick Fleischer and Susanne Portuani in this new teacher journal, which is printed this week. And I will show you a screenshot from CODEP. And here you have a data set. The data set has we use. You see, it's 1,287 cases, and we use the German interface to CODEP. By the way, you see, and we have different variables, and we simplified the data sets for introductory purposes into making these variables binary ones. So, if you own a computer, that is yes or no. But if you Instagram use rarely or frequently, and the original questionnaire had a Likert scale with different from I think 1 to 6 or so. the students could choose, but we made it more simple for the students. And here you have a simple tree on the left with very not very many branches, and I think the misclassification, I cannot read my slides because it's occupied by the videos. I don't know how to can move this. Maybe I can say. Okay, so I put it here. Okay, yes, the misclassification rate is so the prediction is under 13 or over 13, and using only this small number of variables, you can correctly predict in the training data set whether somebody is below 13 or above 13, including 13, with a misclassification rate of 18%, which is not too bad for such a small tree. And the students should learn with activity how to construct these trees, and that it is possible to predict age, which from other variables of the use of social media and whether you own a computer here. What is also very instructive is reading online newspapers. And okay, that is not so much done by young people, students. Okay, so and well, the CODAP tool allows to drag variables from the table into this Arbor, and then a tree is built, and you can successively build several branches. Okay, so here we have the predicted age and the real age, and you see in red the misclassifications which have been made by this simple tree, and which is also interesting to and this is very important, we think, from the beginning, to have a global misclassification rate. That is one point, but also to have different types of errors. So 118 people in this training can continue to use TikTok, although they are below 13. And those with a predicted age are under 13 are temporarily banned, and then they can be asked for an age proof to get free access afterwards. So there are these different types of errors which may have very different consequences, and I think this is very important from the beginning, not only to have a global misclassification rate, but to discuss this. And it is a good context which the young students can understand that these two errors may have different consequences. Okay, so we I will now show you how we introduce this in grade 9 and 11. We have, I quote, some research studies. You will find it in the slides, of course, which will be available after my talk, where we have done research studies, working with students, interviewing students after they have been in our classrooms, and to see what they have understood from the decision trees, and maybe what can we improve. So to give you an insight, how much time do we need now in grade 11? We have 6 lessons, 45 minutes each, to introduce learning how AI works. And then we have another 4 lessons working with this Jupyter notebooks and discussing overfitting and so on. And a lesson ends with 4 lessons learning for life with AI, assessing AI systems with statistical measures and considering social context and for responsible use. So that is the time we need, at least for our units. So I will give you a brief insight into this first unit. So we use we use the same data sets, the GYM data. I already the GYM PB data. PB stands for Paderborn because we collected the data with 1,200 students in Paderborn and some neighbor cities or villages. And the topic is similar. It's also interesting for students. They get personalized advertisement, and the question is, how can an online platform know what are my interests from information of my usage of this platform? And this is also a simple example. And Yannick introduced this from his Instagram feed. And the question is, why does Yannick get such an advertisement for online game? How is this decided in the background by such a system? And we try to reconstruct these processes with a simple data set. And we use this topic, predicting frequency of online gaming from other variables. It's a classification task for a small toy data set. And the data becomes more complex, and the full data set will be given to the students in a later stage. So I will show you this as a very simple example of target variable online gaming, a predictor variable game console, computer, and Instagram frequency use rarely. So the assumption is target variable is a proxy of interest in further online games, and the predictor variables are known into the social networks that it provides advertisements. So that is our assumption. A little bit artificial, of course, but I think that is acceptable. And we use for introductory purposes this very reduced data set with only 14 cases. And now the students should find a decision rule based on these predictor variables. So we start with this very broad prediction. If we just say everybody plays frequently, we have a misclassification rate of 5 out of 14, that is 36%. And building the tree using the information from other variables should help to reduce this misclassification rate. So why may knowledge of another variable help to better predict the frequency of online games? And so we, from our studies with our students, we make a distinction about of the reasoning we observe, and we also encourage in the classroom. So we have on the one hand contextual, causal, probabilistic conjectures, we call it. For example, we can formulate this: console owners are more likely to play frequently than to play rarely, which is also a difficult sentence for the students, of course. Or non-console owners are more likely to play rarely than to play frequently. We can transform this into database conjectures just using the data and replace more likely to, which can be just set based on contextual knowledge or on contextual conjectures. And if we transform this into more often, then we can use data to decide whether this is the case. And so we have in the whole classroom, we will see that these two types of reasoning play an important role and interact with each other. And we call these variables which have this kind of relations informative variables for online games. So owner of a game console, it is of course students, many students think, okay, that is clear in a sense that who owns a game console will play more often online games, or the probability to play is higher. Frequency or owner of computer maybe also an influence. And Instagram use is completely unclear. What should Instagram use? Has it something to do with frequency of online games? One does not know. Okay, in this case, students may wish to look at the data to see whether there is a kind of relation. And so we encourage this causal probabilistic thinking in the first stage of tree construction. And in later stages, we of course communicate that this causal probabilistic assumption should be checked with data, especially when you have a large data set. And we in the later stage, and I will go into my details soon, we of course have to communicate to the students machine cannot reason causal probabilistically. They just use data. So machines use data-based methods, and that can have advantages, but can also have disadvantages. Okay, so how do the students decide whether a variable is informative? So we have observed that some students, we call it eye testing the table. They look through the table and say, oh yes, and check a little bit. If game console, yes, then more often they play frequency. And so that is not a very systematic methods, but that is used by the students. One can, of course, create also a two-way table to make it in a more systematic way. And then you say, okay, if console is yes, 7 play frequently and 2 rarely, aha. So that is informative to know something about console, and that is also similar if console is no, but not so strong. So that is a possibility. And the next option we have is try and check a split. So we can just say, okay, let's try game console. It seems to be informative. And then we check this in a next step here, and we ask the students to sort the data, and it has been advantages even for 9th graders or so to have little stripes, and so that you can really move these rows and to a new position, and then you say, okay, that is frequently and rarely. We have a decision rule tentatively. We have some misclassifications which are highlighted here in the display, and we have, well, not very big success, but we have moved to 4 misclassifications. So we can, refinement of evaluation can be done in various things. I already mentioned the descriptive two-way table, and this is important, which was a descriptive two-way table for the data set can be moved into a confusion matrix where you say here are the predictions and you have a wrong or a correct prediction. So that is very much related, but the confusion matrix is a little bit different than the descriptive two-way table. And this is something we have also to make the students aware of. Then, of course, we have growing a tree, and this is a tree use different new variables, which has a misclassification rate of 7%. Okay, what teacher tips do we give for improving tree construction? We respect the students' intuitive strategies in the first place, and we can build on this. And we have some tips, of course. So do not only rely on visual inspection. It may be help to create a two-way table or to try and check the variable you have selected. And next tip is streamline the selection of predictor variables at various stages of tree construction. Try a different variable and compare the misclassification rates of 2 or 3 variables and select the variable with the best way. And we have also tool use, because to create two-way tables in a data set with 14 cases can easily be done by counting. But if you have 1,200 cases, you should and you have to use software. For all these methods, you have to use software, and we do this with CodeApp. I will show you 2 students. They are pseudonymized, the names are not the real names, of course. And they use CodeApp for creating trees for the topic we are discussing. And these are very different trees the students created. And it is also a pedagogical opportunity for the classroom to discuss, well, how did you create the tree? What is your misclassification rate? What would you prefer? And so on. And Samuel, it's interesting, he was asked to explain how he created. And he said, well, I started, and he explained in context why the chosen variables could be suitable for predicting the target variable. And later, after he had used some of these, what he thought informative variables, he said, I've simply tried out other ones and just database, and until he could no longer find any improvements. And Sandra made it very different. She tested various variables, just trial and check. for the first level of the decision tree, and then she searched for data splits with relative frequencies close to 100% or 0%, so that the misclassification rate should not be that high. And then she stopped the process. And the argument she put forward was, well, if we go into more smaller subsets, these may not be representative. And that is already a certain insight, although we didn't teach this to the students at this moment, that here, if we go on building a very big tree, we really run into the problem of overfitting. And we have very small subsets which are no longer can no longer be representative. Okay, how can the creation process be fully automated? And the ultimate goal of the decision tree, and that has to be highlighted then, is predict future data with low misclassification rates. So here is a possibility of, I will not show it in live, but you see, you can here test to drag always variables into the ARBA module, and then here's a table you can create, and here's the list of misclassifications, and you can just say, okay, I tried 5 variables, let's take this because the misclassification rate is the lowest, and then we go into the next branch, next branch of the tree, and we can grow it, and again go in this systematic data-based way forward. So we experienced in our study that the students, although we taught them this database, the purely database method, that they did not really, all of them did not really understand this. And we took up a day of Andy Ziffler, who also worked a lot on data decision trees and so on, that we introduced to the students meaningless variables. We just hide the names of the variables, and then they are forced to just do data-based decisions, only based on the misclassification rate. And that was quite helpful for the students to understand that the machine is just doing this. The machine does not know what YouTube use means. Okay, so we reflect on algorithmization, and here is a certain algorithm in this kind of pseudocode, which we try to finalize. So the students have made these actions with the different steps, and we try to represent this so that the students understand when they get confronted with a Jupyter notebook what is inside going on in this Jupyter notebook. We can, of course, introduce termination criteria that we say, okay, limited depth, and if this limit is reached, we break, we stop the process. So we have this database Jupyter. I'm running out of time, so I will be. It's menu based, and it's built with a library Yannick has developed, suited for students' use, and the students can use the target variable and depth of trees and so on, and can compare performances on test and training data. So that is a little bit the menu-based Jupyter notebook. Here you can select, can import a data set of your choice. Then you can say, oh, let's take this as a target variable, and we use misclassification rate. The professional algorithms use entropy and Gini index and things. So we have some options, but we do not use them often in the classroom. Then they can create a tree with a depth of 2. And then here's an example of 4. And we have also the problem with big decision tree. So you can create a decision tree with depth 20, which is so complicated that I had to make several screenshots. And you see, and that is also reported here. We have a training data set and the test data. So that is really interesting. That is an important insight for the training data. It's 97% correct classifications. And but if you use test data, it's only 69%. And so in Yannick's Jupyter notebook, we have a possibility to supervise how the misclassification rate simultaneously develops with test and training data. And of course, it goes better and better on the train data. But here you see, if you have a depth, if you would step at a depth of 3, it would be quite good for test data, and it is the best choice for test data. So that is the first insight into overfitting, and the students have some options in the Jupyter notebook to select depths, to do automatic pruning. Also, they say they make manual pruning, meaning that they say, oh, this branch should be deleted and so on. So this is all kinds of options, but you, of course, you can imagine you need time to work with this notebook. So we have these different tools, unblock data cards, and I will a little bit come back to the data cards to give you a little insight, a brief insight. It's a joint work with Yannick and Susanne Podvorny. And we have in grade 5 and 6, we have a recommender system for food items, and we do it with data cards. So data card was something which several years ago, it was already suggested by Chris Renault and Anthony Harradine and others to work just for data analysis, for using data cards to make multivariate data analysis. And we took up this idea for the purpose of creating decision cards. And the idea is we have nutrition information, and we decide whether food is rather recommendable or rather not recommendable. So these are our cards. We have printed them out. They have 55 cards, like a normal card game. And they have these nutrition facts on these cards. And we have several worksheets and slides. And the first point, of course, we have to discuss with the students. We have to label the cards. So we use paper clips, red and green ones. And so the students in our class, of course, it is relatively easy to decide. Apple is recommendable and popcorn is not so recommendable. And there has preceding in this unit, we have some discussion about nutrition in general, what is the meaning of all these numbers and so on. And then after that, there is a labeling process started. And when the cards are labeled, then they are sorted. For example, these are quantitative variables in the gym data. We use binary ones. So here we have not a simple split, but the split has to be found. And this would be maybe a good case to split the data card here. Here we have all green ones. So if we decide green, no misclassification rates, and here we have 2. So this is a whole a little bit different teaching approach to discuss with the student how to find good split in creating the decision tree. And here we show you some examples. We can use fat and other things and label the data, and we also have use embodiment. So it is also well known as a pedagogical measure to the students represent food items. They get a card, and then they resort themselves in the classroom into groups and subgroups and so on. So they build a decision tree by moving around in the classroom. And when they have done this, this can be also done with data cards later on. And I like to end with here with some pictures what the students did, the 6th graders with the data cards. And we had a very nice final event in one of our schools with whom we collaborated. Was the motto was AI meets theater education. The theater project was Apple versus popcorn. Why not ask an AI? And here you see the students, we have printed out the data cards as posters, and the labeling is done by caps. So you see ketchup has a red cap, is not recommended, and bananas and carrots and so on have green caps. And so the students play a certain food item, and then they move around and build decision trees. And the students were very creative, and there's a film, a movie on our website on this. So they had all own ideas how to enrich this as an interesting theater play. Okay, but this is not done regularly, but we have these data cards, and we produced 2,000 sets and distributed it to schools free in our state, and that is well received doing decision trees with data cards. Okay, I come to an end. I will not talk about information on Jupyter notebooks more than I did so far. And thank you very much for your attention.
Thank you very much, Dr. Biehler. We have about 5 minutes for questions. So there's two different ways that you can post these questions. We have a Q&A form where you can type in your questions directly, and then I will read them out loud. Or you can also raise your hand, and then we can ask you to unmute yourself, and you can ask your question live. So we'll those two methods for anybody to post any questions. I'll give you a second to start typing those out and see if we have any hands raised. Okay, the first question, the food cart activity seems like it was very effective on many levels. In which subject was the activity introduced? Was this a science lesson, a technology lesson, a math lesson, etc.?
Okay, so we had, in fact, we used several contexts. We had it in biology and in mathematics, but most of them were done in the computer science classes, which have become obligatory, as I mentioned briefly, in our state. And so they used it in these computer science classes, and it's clear what can we do with decision trees and artificial intelligence with 5th graders. And so this was well received as an interesting idea to use this data cards. And also other states in Germany were interested and have also created their own data card sets and so on. So this more or less was and also I may mention this, also older students like to use data cards, even teachers do. So when we and so I've a little bit skipped these slides. So now we also in grade 8 and 9 we start with data cards because we find that people think that is fun to do, to work with these practical haptic things and as an introduction to create your own trees and then move on to more computer-supported things.
Excellent. Thank you very much. We have another question in the chat. Several times you talked about starting with toy data and building up from there. What's the guiding principle that you use when creating a data set that students first see, or does it vary?
Well, the toy data set I showed you was was a subset of the real data set, but we reduced the number of variables and the number of cases. So we had instead of 1,200, we had only 14, so that the students were able to do the decision tree construction by manual manipulation or by scanning the relation between two variables, which is impossible if you have 1,200 and so on. So that was our criteria, but we did not completely invent this data set, but it was a subset from the data we collected.
Excellent. Thank you very much. We have one more question from the Q&A. From what age is computer science taught? Is the food science card activity typical of an introductory lesson that is further than developed over a period of days or weeks?
Well, so in the curriculum of our state, North Rhine-Westphalia, there is this obligatory topic, and so the food item is the only introduction to decision trees at this level. But then in grade 9 and 10, we have only non-obligatory courses for computer science, and they have in their curriculum now also the topic of decision trees, so they may take up the topic. And as I said, in the food item, we did not talk about overfitting and all this stuff. So but we can do this with other data and later in grade 8. And so it's taken up, and we just are a little bit involved in a revision of the computer science curriculum for grade 11 to 13. And this is also now have units on artificial intelligence. So but it's also non-obligatory. So I will not convey the message that every class in Germany, except 5 and 6 in our state, it's the biggest state, but nevertheless, it's one state only. The other courses are non-obligatory. So the students can choose it. It's not they are not forced to do it. And so if they choose it, then they get the decision trees and artificial intelligence resumed on higher levels during their school career.
Excellent. Well, thank you very much, Dr. Biehler. And that is all the time that we have for questions. There's one more comment that I'd like to read out loud. The work is quite impressive. It is amazing what you're covering in these elementary and middle school classrooms. And so on behalf of all of the attendees, as well as the entire COS community, thank you very much, Dr. Biehler, for sharing your work with us today. And thank you to all the attendees who've attended this session. We have breakout sessions starting in a little bit, and we've posted the links in the chat, as well as if you are interested in continuing the conversation, please do so on the eCOTS 2024 channel in the COSWeb Slack. So thank you very much, everybody. Thank you very much, Dr. Biehler, and happy continuing eCOTS. Looking forward to interacting again in the breakout sessions starting in 15 minutes.
Okay, thank you very much. And if you have questions, write me an email. The slides will be shared over your website. I will send them to the organizers, so you can, of course, contact me if you have more interest in our materials and everything. I'm happy to share other things with you if you are interested in. Thank you very much. I'm sorry that I used a little bit more time than I expected to use, but I wanted to come back to the data cards and finally to give an interesting insight into this as well. Sorry.
No problem at all. It was very interesting to listen to. Thank you very much.
Okay. Have a nice